everyone, Mr. Aarons. Last time that we recorded, I was working on rational numbers. Today we're going to do the second half of that. Should be pretty short, simple, a little bit of a combination of some other things that we've already done. Let's dive in. 4-6 rational numbers. First off, I'm just going to have us redefine these real quick. I remember a rational number means can be fractioned. Oops, I wrote can be fractioned. And irrational numbers mean it cannot be fractioned. What this is saying is that these numbers you can make into a fraction. These ones you cannot make into a fraction. Right here I have our little helpful hint here. Shows us a diagram of whole numbers, and then inside of that is inside of integers, and inside of that is rational numbers. Outside of rational numbers, these would be the irrational numbers. So anything inside this green circle, these are all rational numbers. They can all be made into fractions. We talked about that yesterday. If you missed that lesson, go back and watch that. So today what we're going to be doing is we're going to be using rational numbers to do some things that we've already done, simplifying fractions, making equivalent fractions, evaluating. We're putting it all together. So the first thing I want us to do is have us write some equivalent fractions. Your key to do that, this is your key step right here. Multiply or divide the top and bottom numbers by the same numbers. That's how we can make our equivalent fractions. For example, if I have 1/2, I can make an equivalent fraction by choosing to divide or multiply each number right here by the same. So I'm going to do that right now. I'm going to do times 2. Times 2 on top, times 2 on bottom. That would give me 2 on top, 4 on bottom. There's an equivalent fraction. 1/2 is the same as 2/4. If we want to, we can draw it out real quick here. There's 1/2. There's 1/4. There's 2/4. They're the same amount. We could also do this, and then instead of times 2, we could say let's do times 8. That would make 8 on top. 1 times 8 is 8. 2 times 8 is going to be 16. I could draw that one out too. So it might take a little bit. Ooh, this one's going to be small. It's going to look all filled in. 1, 2, 3, 4, 5, 6. Oh, I need one more. 7, 8. Again, 1/2. One more time, we could times it by any number of your choice. Watch this. Times by -3. Doesn't matter. Times by -3. Perfect. Let's do -3 on top, -6 on bottom. We know a negative and a negative cancel each other out, so this is really just saying +3, +6. There's 1, 2, 3, 6. They're all the same. Those are all equivalent fractions. Do a couple other examples here. We have 1/3. We can multiply that each side by 2. That's going to be your simplest one usually, is to multiply each side by 2. Get this to 2/6. Those are equivalent. We can multiply them each by 10. That's another simple step to get there. Puts 10 on top, 30 on bottom. Again, equivalent. We got all these equivalent numbers to 1/3 right here. These ones are all equivalent to 1/2. Go down here. Multiply or divide each side by the same. The reason I'm choosing not to divide right now is because I'm doing pretty small fractions. I'll do an example with a bigger one. I'll toss it down here. We'll make it 10/40. 10/40. We'll toss on in there. Get to that later. I'll just do a couple examples here. We have a negative number. That's okay. As long as we still multiply and follow the same rules, that is okay. Let's multiply by 2. It's -8 on top, 10 on bottom. Checks out. Works out. Multiply by -2. That would put +8 on top, -10 on bottom. This works out as well because negative divided by a positive, positive divided by a negative, they're both going to be a negative answer. They're both going to be a negative answer, so that works out. That is okay. These are the same thing. And one more example right here. We got 5/8. Multiply top by 5. bottom by 5. I'm choosing the same number on both. Perfect. I get the gist of that. Or multiply or divide the top and bottom number by the same. Here I'm going to do some division. So check this one out. Instead of multiplying now, I'm going to divide by the same number. I'm going to divide each by 10. 10 divided by 10 is 1. 40 divided by 10 is 4. That is an equivalent fraction. I could divide each by 2. 10 divided by 2 is 5. 40 divided by 2 is 20. Equivalent fraction. Here I'm choosing to divide because I have a bigger fraction. Sometimes it's not always going to divide out perfectly. That's why multiplying is a little bit easier to write equivalent fractions with. But yes, you kind of divide as well. Multiply or divide the top and bottom number by the same. All right, moving on to the back side, we're going to simplify some fractions here. Sometimes you'll see something like this. What we can do with fractions, this is going to stray a little bit from what you might expect with PEMDAS. But in order to do this, you can imagine these are in imaginary parentheses. Anytime you see this, toss those right into parentheses. They're locked in with these parentheses. I can't start dividing stuff top and bottom until I figure out what's really on top here. So what's really on top here? Well, it's 1 plus 9 plus 2. 1 plus 9 is 10, plus 2 is 12. We really got 12 on top. On bottom, we have 2 minus 5. Positive 2 minus 5 is going to get me to negative 3. This is what my fraction really is. From here, what we can do is we can simplify this. When we're simplifying here, we have to find the greatest common divisor. We talked about that last week. This is where our trees come in. Negative 3 it can't be broken down anymore. It's already at its bottom. Negative 3 is itself. This one we could break down to 3 and 4 and 2 and 2. We're looking at what they have in common. This would be 3 and negative 1, you could say, but really just a negative 3. What do they have in common? They have this 3 in common. So what are we going to divide them by? Divide them each by 3. Gets us to 4 over negative 1, which is the same as negative 4. We solve for the top. We solve for the bottom. Put them together. Simplify by finding that greatest common divisor. We talked about that last week. If you missed that, go back and watch that lesson. One more example of that here quick. We got 12 minus 6 plus 1. 12 minus 6, I know that is 6, plus 1 is 7. 7 divided by 16 plus 2 is 18. I'm not sure if this is in the simplest form. Let's check it out. 7. That's a prime number. It can't be broken down any further. 18. We break down to 9 and 2. Break this down to 3 and 3. They have nothing in common. If they have nothing in common, that's our simplest form right there. All done. We solved that top. We solved that bottom. Found our answer. Sometimes they'll ask you even to evaluate. We know how to do this. Don't let this confuse you. They tell us for this. For this. What that's really telling us to do, take this A equals 6, B equals negative 5, and plug them in. Watch what I do here. I have this one right here, A plus B divided by negative 3. I know A is 6. I know B is negative 5. Divided by negative 3. Easy peasy. On top, this becomes a 1 divided by negative 3. Blammo, we're done. Next one, let's do the same. We got 7 minus B over 3 times A. 7 minus B, I know, is negative 5. Divided by 3 times A. I know A is 6. Let's plug them in. Took those, plug those right in. 7 minus negative, I know that really means plus, equals 12 over 3 times 6 is 18. Now we have to simplify. This is not its simplest form. Here's where we use our common divisors. Let's do it. Break these down a little bit here. We got 3, 4, 2, 2, 9, 2, 3, 3. What do we have in common? They both have a 3. They both have a 2. Our common divisors are 3 and 2. We multiply them together to get our greatest common divisor of 6. What do we do with that? We take it right up here, divide each of them by our greatest common divisor. We get to 12 divided by 6 is 2. 18 divided by 6 is 3. Final answer. All right, one more. We got a plus 9. We know a is 6, so 6 plus 9 divided by b is negative 5. Let's do it. On top, we got 15. On bottom, we have negative 5. We got to figure out those common divisors. Figure out what we can simplify this to. 5. This is going to become a 5 and a 3. Those are both final form. Negative 5, it doesn't really matter that's a negative. It just matters about the prime numbers within it. We know it just is 5 and 1. What do they have in common? They both have a 5 in common. Let's divide each side by 5. That kind of squished up here. I'm going to bump it up here. That's going to become 15 divided by 5 is 3. Negative 5 divided by 5 is going to be negative 1. Final answer is negative 3. Take those steps that we've been working on. You got to put this stuff together. If you've missed other lessons, you're going to need to go back and watch before you go through this one. Rational numbers, get this down in your notes if it helps you. Crush it today.